All right, so on Friday, we covered all of the things to do with polynomials, addition, subtraction, multiplication. The only thing we didn't get to was division. Thankfully, in this class, we only cover dividing a polynomial by a monomial, which makes life a lot easier for us. If you do a polynomial by a polynomial, you have to do like a long division. It gets very complicated. It's something you have to do in Math 96, but not in Math 92. So what we're going to be using to do this division of polynomials is we're going to be using the rules for adding fractions sort of in reverse. So if you wanted to add two fractions, right, as long as they have common denominators, you just add the numerators, right? So we can see here in the numerator, we have a bunch of things added together all over one denominator. That's the beauty of having a monomial in our denominator. So if this is the case, we can basically use this rule in reverse. So if I want to have two things divided by 3, I can just divide each thing separately by 3. So that's exactly what we're going to do here. So one way to do this is to actually write out the division. Right? We have the first term of our polynomial divided by our monomial that was on the bottom, plus the second term over what we had, plus the third term over what we're dividing by, and then our final term over what we were dividing by. And then you just treat each of these new terms as separate instances where we just need to do our division and use our exponent rules. And if you want to, you can move very slow on this. Neither of these two steps is really necessary, but we don't want to skip anything the first time. So the numbers, well, we can sort of think of this as, right, this first term. We can think of this as 5 divided by -5 times x to the third divided by x. Because if we were doing this multiplication, we'd just multiply the numerators and multiply the denominators. So this is what we're going to do mentally in our head each time. And if we're doing this division where we have two things, same base raised to different powers, we're just going to end up subtracting those powers. So I'm going to not rewrite this part. I'll leave the 5 over -5 because it's not a bad way to stay organized. But I'm going to change this to x to the 3 minus 1, right? We know the quotient rule for exponents tells us that we just subtract exponents when we are dividing two things, same base, different powers. All right. So you just keep doing this. 15 over -5, x 2 minus 1. We have plus -10 over -5, x to the 1 minus 1. And then our last one, 25 over -5. And then I guess if you wanted to, you could think of this as x to the 0 over 1. This is x to the -1. This particular one, I wouldn't have rewritten this way, but I'll kind of show you how I would do that as we simplify each of these. So simplifying each of these, we've got a negative x squared, a -3x to the first, which we don't need to write. We have a positive 2. This becomes x to the 0, which is just 1. And then we have a -5. And we should actually put that x in the denominator. So in reality, I wouldn't have done this piece here. I would have just said, okay, there's nothing this needs to cancel with, so let's leave it in the denominator. Being careful not to do what we saw happen for a lot of those groups on Friday, where we really want to get rid of that denominator, so we kept moving things up into the numerator even when it wasn't allowed. Again, use your patterns to sort of double check your work. You could see in the original polynomial, 2, invisible 1, 0, right, on our x. And you can see them again here. We went from 2, 1, no x's, and then an x in the denominator, which is actually that -1 exponent. So use those patterns. Like if you ended up with an x up here in the top, right, an x up here, you should realize something is wrong because we were going and descending and all of a sudden you have an x again, and that doesn't make sense. So use the patterns to your advantage to check your work. All right, so I'm going to give you guys one more of these to try, a little bit tougher. So take a moment, pause the video right now, try this on your own, and then come back when you're done to check your work. Okay, so I'm going to assume you were good and actually checked your work. So first things first, you don't need to rewrite every single one of the terms over your denominator. You can. It's a good organizational tool, a good way to make sure you're not making any mistakes. But you can just realize I'm going to take this and divide every single term of my numerator by that denominator. And then you can just do that in your head as you get better. Since we're not necessarily there yet, I am actually going to rewrite all of them. A little silly, but that's what I'm going to do. Don't worry about sign changing. My denominator is positive, so whatever the sign was on the numerator, I'm just going to keep that between my terms. This one in particular has the most worry in terms of, oh, I added a square. Crazy. Has the most worry in terms of accidentally moving things back into the numerator, not leaving in the denominator, if that's what's supposed to happen. So first one, we have 30 divided by 2, which is 15. We have an x to the third over an x to the first, which is going to be x to the 3 minus 1, or 2, right? Same thing with the y's. We have a y to the 5 minus 2, which is just the same thing as y to the 3. And then the next one. 15 over 2 does not simplify, so we are going to be stuck with a 15 and a 2 in the denominator. You can write this as a coefficient, or you can write it all as one big fraction. Either is okay. I'll go ahead and do both so you can see what the difference would look like. If you leave it as one big fraction, let me move that fraction up a little bit so it's a little cleaner looking. We would have 15 over 2, and then you decide what's happening with the x's. All right, x squared is bigger, so we end up with an x in the top. The x squareds are going to cancel, or the y squareds are going to cancel. So there we are, and you move on. You also, like I was saying, you could have written this as negative 15 over 2x. You can write that 15 over 2 as a coefficient, or as the whole term as a big fraction. Either one is the same. All right, so the next one, 16 divided by 2 is 8. Looks like we're going to cancel out x squared over x is just going to be a single x. And here we get something a little less happy for us. We have y over y squared. So if we were to actually do our exponent rules, this is y to the 1 minus 2, right? 1 in our numerator, 2 in our denominator, which will give us y to the negative 1. Most textbooks, most teachers want you to always have your positive exponents. So what we should do here is we should go ahead, leave our fraction and put the y in the denominator here. I always think of these things as sort of a boxing match, and in this case, y squared is bigger, so that's why our y is going to end up in the denominator. So there's our third term. And then the last term, similar again to the previous one. 8 does divide evenly by 2, so we end up with 4. The x's cancel and just turn into 1, right? That's just a factor of 1. And then again, we have y over y squared. Same deal, we're going to have y in our denominator. So your final answer, I'll go ahead and rewrite it down here since I was on that weird section, would look something like this. And that's it. That's dividing polynomials. It's mostly just a lot of simplifying and a lot of chances to make mistakes, which is why it's not a bad idea to take all of these steps to show your work and make sure you don't make them yourselves. All right, that's it.